is for Chapter 23, Section 1, Part B, covering parallel circuits. Here in this figure is an example of a parallel circuit. A circuit in which there are several paths for current to flow is called a parallel circuit. Current can flow through resistor 1 and through resistor 2 and through resistor 3. So there's different currents, not one big loop like a series circuit. And in a parallel circuit, the total current that comes from the generator or the battery is the sum of the currents that come from each one of the resistors. So think of it as water in a pipe. Some water goes down R3, some water goes down R2, some water, so many gallons per hour, go down R3. All that water is coming from the generator. So all those gallons of water flowing in R1, 2, and 3 come from the generator. Or in other words, you have to have enough water from the generator equal to the sum of all the water you need or all the current you need in the individual resistors. So again, key to remember, in a parallel circuit, there is more than one current, and the total current through the generator or through the battery is the sum of all the currents that flow down through the different resistors in the circuit. Let's have a look at figure 7. It's a good one to study, showing a parallel circuit. Now first off, notice that the source or the battery is connected by wire to each one of the resistors, on the top and on the bottom. Wires don't change voltage, they just move electricity. So if there's 120 volts on this battery, there's 120 volts on each one of the resistors. In a parallel circuit, the voltage is the same on all the resistors. Once you know the voltage, you can use Ohm's law. For example, Ohm's law would predict a current saying we take 120 volts and divide by 6 ohms and you get 20 amps. Because the resistors are different, the current is different. So the current through a parallel circuit can be different. But where does all that current come from? It's coming from the battery. So all the current comes from the battery. So the battery has to provide 38 amps in order to provide enough current to each one of the resistors. So the voltage is the same on all the elements, and the current from the battery is equal to the sum of all the currents needed. Okay, let's talk about equivalent resistance. In this case, let's just look down at the formula. Last time for a series circuit, you just added the resistors. This time, for a parallel circuit, you add the reciprocals. So it's a different formula, and it has a different result. Remember last time in a series circuit, if you added more resistors, the total resistance or equivalent resistance went up. When you use this formula, what you'll discover is the equivalent resistance is always less than any of the resistors in the formula. Notice that this resistance is smaller than any of the 3 resistors in parallel. Placing 2 or more resistors in parallel always decreases the equivalent resistance. The resistance decreases because each new resistor provides an additional path for current, thereby increasing the total current from the battery. So if you get more current for the same voltage, that means you have less resistance. Equivalent resistance goes down. Think about it over here in the picture. As we add more resistors, there's more opportunity for current to flow, so we're going to need more current out of the battery. If you get more current from the battery, that means the resistance is lower. And as we talked before, the current from the battery is equal to the sum of the currents in, that's a typo, that should be a plus sign, is the sum of the currents in the individual resistors. Now, I want to just briefly talk to you about these two rules that are at the end of the chapter. They're not really important unto themselves, and I think you've largely learned them already. I just want to kind of take a moment to pull together what you've learned. One of them is called the loop rule. Basically what it says is the sum of the voltages around a loop is equal to 0. The way I like to think about it is if you go up, if your charges gain energy through the battery, they lose that same amount of energy coming down. What this amounts to is, let's suppose you go up 12 volts through the battery. That means you're going to come down 12 volts and then go around in the circuit, go up 12 volts, and let's suppose you go down 4 volts in R1. How many volts would you go down in R2? Voltage drop. Well, if you go up 12 and down 4, you have 8 more to go down. That's all this rule says, is that whatever you go up on the battery, you got to come down through the resistors. Or whatever positive voltage you get from the battery, you're going to lose that voltage on the way down through your resistors. It's a sense, it's a conservation of energy. Now there's another rule. We've talked about it already, just show it to you briefly, called the junction rule. It just basically says in a circuit, if you look at the current is like the flow of water. So if we have a pipe that splits into two different pipes, all we're saying in this rule is that if you have 100 gallons of water per minute coming in and 25 gallons go this way, 75 gallons have to go the other way. Or in terms of charge, if you have so many amps coming in here, they need the sum of the amps going out in these two directions has to equal what comes in. It's really just conservation of charge.